Okay, today we are moving on with the hyperbolas. Basically just same kind of form that we did with the ellipse. You know, ellipses we started at 0, 0, and then we moved them. That's what we're doing today. Okay, we're going to take this hyperbola and shift it off the center just like we did with an ellipse. Okay, situation is the same. Look up here. Okay, the H always stays with the X, no matter if it's a vertical or a horizontal, and the K always stays with the Y. Okay, in this case, your H and K is going to be the center of your box. Okay, so instead of it being the center of your ellipse, okay, it is actually the center of your box. Okay, which obviously has to be very well pronounced or it's going to be hard to find. But other than that, the only other thing that's difficult is the foci, because we have to shift it based on where our center of our box is already located. Okay, so when we add that square root to it, we have to go from here out or from here up, depending on what kind of hyperbola it is, rather than just easily adding it to 0, which is what we've been doing before. Okay, so let's look at this guy. Again, same thing goes. We decide if it is a horizontal or vertical. In this case, it is a horizontal ellipse. We are on the x-axis, which means that x gets to go first. Okay, and then our y gets to go second. Okay, we are shifted off of the center. The center coordinate is going to be 2, -1. Okay, x always stays with the x. Okay, remember, minus a minus is actually going to give us a positive. Okay, and it's stacked on top of the same thing it was before, the width and the height of the box. Okay, this box is 2 units. Oh, sorry, it is 1, 2, 3 units high. Okay, so we are over 9. 3 squared is 9. And it is 1, 2, 3, 4 units wide. 4 squared is 16. Okay, again, we're counting from the center out, the center to the edge of the box, the center to the top of the box. That's how we're getting these numbers right here. Okay, our slope doesn't change. Our slope is still the square root of the y over the square root of the x. Okay, so we still have positive, negative 3 over 4. And here's the only difficult part, is our foci. Just like before, we need to determine if our foci is going to be on our x or our y-axis. In this case, it is going to be on the x, because it is inside the parabola. Sorry, it's eating the foci. Okay, which means that our y-coordinate is not going to change. So our y-coordinate of -1 is going to stay the same. Okay, we're not moving this foci up or down. He's literally just going to be right along this center inside the parabola. Okay, so let's figure out where. Okay, 16 plus 9. Is actually the square root of 25. Okay, the square root of 25 is 5. So we are going to add that 5 to our current x value, and we're going to subtract that 5 from our current x value. Okay, so we have 2 plus 5, which is 7, and 2 minus 5, which is -3. So now our foci is at -3, -1, and 7, -1. Okay, so he's right here and right here. It's always nice when it's a pretty little round, nice, even, perfect square right there. Not going to happen often, so don't get used to that. And same rules for a vertical ellipse. Okay? Minus, not ellipse, sorry, hyperbola. Minus, because it's a hyperbola, still set equal to 1. Okay, this time our center is at -4, 3. Did I see that? -4, 3. It's right in between the 2 and the 4. Okay, so for our x, we have minus a minus, which would give us a positive, and then y minus our 3. Our x, let me zoom in so we can see how many units this guy is. Okay, width, he is 1, 2, 3, 4, 5, 6, 7 units wide. So we're over 49. And then he is 1, 2, 3, 4, 5 units tall, so we're over 25. Okay, bad thing about me being there is if y'all see a mistake that I make, you're just going to have to roll with it and go with my mistake through the whole problem because you can't yell at me to change it like you normally would. So, there's that. Okay, so we're just going to roll with these numbers, whether I counted wrong or whatever. We're going to roll with them. Ooh, and look what I did. That's one thing that y'all did not call me out on. Okay, it is a y hyperbola, so who gets to go first? The y gets to go first. Look what I did. That was a big old oops. Big old oops. Let's flip-flop those fellas. And we said it was 25 over 49. So sorry. Okay. Now for our slopes, rise over run, always y over x. So plus or minus, the square root of that is 5 over 7. Okay, and in this case, our foci is going to change our y value. Okay, because we're going to go up and down with our foci. We're not going to move them left and right, so our x is going to stay exactly the same. So our foci are all going to have, or both, going to have a x coordinate of -4. And whatever we figure out for the foci, we're going to add it to this current y coordinate of 3 because we're actually going to be starting from here and adding our foci to that. Okay, so starting from 3 and adding our foci to that. So let's see what it is. We have the square root of 25 plus 49. Okay, and 25 plus 49 is the square root of 74. Okay, so I'm going to leave it just like we did with an ellipse. We're going to do 3 plus the square root of 74, sorry. And then the other one is 3 minus the square root of 74. Okay, for those of you that are wanting to graph it, that's going to be at -4. And for this one, 11.6. And for the other side, it is -5.6. Okay, again, that's if you want to graph it. So it's right here, and then 11.6 is up here somewhere, and 5.6 is about right there. Now I got a little crooked. Okay, flip it. Let's do some more practice. Okay, again, the foci are the hardest things about these, only because we have to focus on where our center currently is when we add the foci to it. Okay, the rest of the stuff is just like it was before. Okay, so here is my center of my box, and that is at -1, -2. Okay, it is an x hyperbola, so my x is going to go first. Okay, so we have x minus our x coordinate, which would give us a +1. Minus a minus is positive. Y minus a minus also becomes positive. And let's stack these on top of their height and width. Okay, the width of this box is 2 units wide, so 2 squared is 4. And it is 3 units tall, so over 9. 3 squared is 9. Okay, the slopes of these lines, the slopes of these asymptotes right here, rise over run, y over x. So we have plus or minus 3 over 2. And the hard part is the foci calculation. Okay, again, ask yourself, our foci is going to remain on this x, which means we're not going up and down at all. Okay, so our x coordinate is going to change, the y is going to stay exactly the same. So our y is going to stay at -2. And we have 9 plus 4, which gives us the square root of 13. So we are going to add and subtract that from the current value. So we have -1 plus the square root of 13, and -1 minus the square root of 13. Again, for those of you that want to graph that, it gives us 2.6 and -2. And -4.6 and -2. Okay, we should put our foci right here and right here. Okay, y hyperbola minus determines it's a hyperbola rather than ellipse. Set equal to 1. Okay, my center is located at -1, 2. Since y gets to go first, y coordinate is -2. That's actually +2, but when you put it in, it becomes 2. Okay, and this one, x minus a minus would give us a +1. Okay, the height of this guy has 2 units tall. 2 squared is 4, and it is 1, 2, 3, 4 units wide, which puts us over 16. Our slopes, again, rise over run. So rise is going to be our y. So plus or minus 2 over square root of 16, which is 4, which of course is plus or minus 1/2. Yes, it is important that you simplify that. And for the least favorite part of the asymptote, not the asymptote, the foci, sorry. Okay, our foci. Let's think about where it's at. It's the y coordinate is the one that's changing, not our x. We're not shifting left and right anywhere, so we are going to maintain that x coordinate of -1. And our y is what's going to change. Okay, so we have the square root of 4 plus 16, which gives us the square root of 20. So I have 2 plus the square root of 20, and 2 minus the square root of 20. Okay, again, for those of you that want to visually see where that is located, this one is going to be at 6, almost 6.5, 6.47. And this one is at almost -2.5. So right here and right here. number 3. I hope y'all are seeing how much these relate to an ellipse. Okay, a few things different. You have to determine x or y, which one goes first, and it's a minus rather than a plus as far as the ellipse goes. Okay, so we have another x or hyperbola. Okay, let's find that center, and he is right there. 1, -1. Our y coordinate is 1. Whoops. Remember, it's always minus something. The only time it changes is if you have a negative right here and then it flips to the opposite. Okay, well, they kind of both flip, to be honest. This is supposed to be a positive one. It looks like negative. It's supposed to be negative, looks like positive. Okay, let's see how wide it is. So for our x width here, we have 1, 2, 3, 4. And height-wise, it's 1, 2, 3. Which gives us a slope of, again, y over x, so positive, negative, 3 over 4. And our foci are at 16 plus 9. Which again is the square root of 25, which equals 5. So we're going to add that to our current x coordinate. Okay, our current x coordinate is going to change, not our y. Okay, so we have 1 plus 5 is our x, -1 is our y, 1 minus 5. And of course, when we simplify that, we get 6 and -1 for our foci, and -4, -1. Whoops. So there are your foci right there. Okay, number 4. It is a y hyperbola. Okay, and this time we were at 0, -1. So technically, I don't have to move him at all for my x coordinate, and my y is going to be 1. Okay, the width of this guy is 1, 2, 3, 4 units wide, so we're over 16, and 5 units tall, so we're over 25. Which gives us the asymptote of plus or minus 5 over 4. Square root of 5, or square root of 25, square root of 16. And for our asymptote, we are staying put left and right, so our x coordinate is not going to change. Okay, our x coordinate is still going to remain 0. And this time our y is going to change. So we have the square root of 25 plus 16, which is the square root of 41. Super ugly. So we have -1 plus the square root of 41. -1 minus the square root of 41. Okay, again, for you visual people that want to see where that is, this one is at -7.4. And this one is at 5.4. So right here and about right there. Remember, inside the parabola, that's a big important thing you have to make sure of. That totally changes this coordinate. Okay, I literally just graphed 0, 5.4, and I'm inside my parabola, so I know that I did this correct. Okay, 0, negative 7.4, I know that I did that right. Okay, flip it over. And again, these easy multiple choice questions. Okay, y, x, so we're looking for a y hyperbola. See if we can eliminate anybody. And they're all y's, so I can't do anything there. Okay, I do know that my center is going to be at negative 3, positive, oops, sorry, not sure. My x is positive 1, and my y is negative 3. So I'm looking for a center at 1, negative 3. Okay, so he's good. 1, that's 1, positive 3. That is negative 1, negative 3. And this one is 1, negative 3, so he can stay. Okay, so now I have to look for 2 units wide and 2 units tall. 2 wide and 2 tall out of the only 2 options I have left. Okay, so from the center up, this one is 2 tall, but it's only 1 wide. Okay, this one is 2 units tall and 2 units wide. Okay, be careful. Don't do what I just did when you're naming the center up here. Okay, I immediately started writing down negative 3, positive 1. Okay, I forgot x stays with x, y stays with y. Okay, big thing you need to focus on right there. Okay, let's look at this guy. Does give us a graph. Okay, write the equation of a hyperbola in standard form with vertices located at 5, 3. So 5, 3 is one of my hyperbolas, or one side of my parabola, I should say, that goes with my hyperbola. And negative 1, 3. Okay, these are going to be my vertices. And my foci are at 7, 3. And negative 3, 3. Okay, that's important because now I know which way that it opens. Okay, I know that my parabolas are opening this way, which gives me a hyperbola, an x hyperbola. Okay, exactly halfway between these 2 vertices is going to be the center of my box. Okay, so if it's 1, 2, 3, 4, 5, 6 units, 1, 2, 3 units is going to be my center. So my center here is at 2, 3. So I'm looking for an x minus 2, y minus 3 when I go up here to look. Okay, minus 2, we're good there. And I'm looking for minus 3, and we're also good there. Okay, another one that you can easily eliminate. Look at this positive. Okay, that is an ellipse. We are not graphing an ellipse. It clearly says graph the hyperbola. Okay, the plus would make it an ellipse. Okay, how wide is this guy? Those are the only 2 differences left. Okay, he is 1, 2, 3 units wide, making it x over 9. So there's my only option. Okay, I understand the box is not there, so you don't even know how tall it is. Okay, you don't know, but you do know for a fact that it is 3 units wide, making 3 squared 9, so that has to be the answer choice. Okay, this one would be 4 units wide, which is not correct. Okay, and that is it for today.